Hello again. Welcome to another lesson in Algebra 1. Today we're covering section 5.6, Fit Aligned Data. All right, so if you have not tried this warm-up, please pause the video. It does you no good to copy these things. This is great practice and helps you get ready for our test. So pause the video, do it yourself, and then come back and check, okay? All right, so number 1, part A. Plot the points 0, 5, and -3, -3 on the coordinate grid. So 0, 5 is 0 left and right, and 5 up. 1, 2, 3, 4, 5. And -3 is 3 to the left and 3 down. Okay. Draw a line through the 2 points. Okay, so let's draw a line. What is the slope of this line? Count it on the grid. So use the grid to help you find the slope. We don't need to use those 2 points to calculate it. We can just count it on the grid. So this is 3, 4, 5, 6, 7, 8 up and 3 over. So our slope here is going to be the change in the y, which is 8, divided by the change in the x, which is 3. What is the y-intercept? The y-intercept is the place where this red line crossed the y-axis, which was at 5. It's right here. Okay. So what is the value of y when x is 0? Now write an equation for this line in slope-intercept form. So we know the slope and we know the y-intercept. So slope-intercept form is y equals mx plus b. And I'm just going to replace the m with 8/3, and I'll replace the b with 5. So 8/3 x plus 5. What is the slopes of all lines that are parallel to the line in exercise E? So remember, parallel lines all have the same steepness. So these will all have a slope of 8/3 also. Now write the equation of a line that is parallel to the line in exercise E. So we're going to be parallel to that same red line and goes through the point 6,2 in point slope form. Okay, so point slope form is y minus y1 equals the slope times x minus x1, where the y and x come from this point. There's point x1 and there's y1. So I'm going to do y minus, and the y coordinate was 2, equals the slope, which has to be the same slope because that makes it parallel, and then x minus the x coordinate, which was 6. Now graph your equation from exercise G by plotting that point and using the slope to get another point. All right, so we'll go ahead and graph this one. So we're going to plot the point 6,2. That's 6 to the right and 2 up. Okay, and then we're going to use our slope, which is 8/3. So we go up 8 and over 3. 1, 2, 3 will put us there. And here is our line. And you can notice, even with my kind of crooked lines here, it looks parallel. Okay, so 2 lines are parallel if they have the same slope, both have the slope of 8/3, and different y-intercepts. Okay, one of these y-intercepts was at 5, and the other one is way down the grid here. Okay, on page 2, we start off with the definition. So a scatter plot is a graph used to determine whether there is a relationship between paired data. So paired data means ordered pairs. So is there a relationship between x, y? Scatter plots can show trends in data. So in other words, people use this to try to determine, is the data increasing or decreasing? Okay, so we're looking for, in our case, linear trends. We're looking for things that will form a line. So notice in real life, the data points aren't always going to be line up straight. So if we put like a plot of a person's height versus their weight. Now obviously the taller they are, the more they're going to weigh, and the shorter they are, the less they're going to weigh. But there's going to be people all around in these spots, okay? And for the most part, this is going to be true. The taller you are, the more you'll weigh. But for some people, you might be really tall but be skinny, or you might be really short but be fat, okay? But for most people, we're going to find that the general trend in this data is a linear equation going like this. Okay, and that's all a scatter plot is. We're looking for some random real-life data, and we're trying to put some trend in it. How's it working? So the first one, notice this is like our height and weight data. the trend is it's going up from left to right. So this is a positive trend because the slope of this line that we could draw through it would be a positive slope, m is greater than 0. In our second one, the data seems to be going downwards from left to right, so we get a negative correlation, and that's because the slope is less than 0. And in our third one, there's relatively no correlation at all. There's no way I could draw a line that's better than any other way. Okay, so this has relatively no correlation, so it doesn't have a slope at all because it just doesn't make a line if I try to connect or draw some line of best fit through them. Okay, all right, so let's see if we figured out anything from this. Describe the correlation of data graphed in the scatter plot. So in this case, this would be a negative correlation. We could draw a line that would be pretty close to all the dots, and this line would have a negative slope. So this would be a negative correlation. Okay, and in our second one, probably no correlation. Okay, I could maybe say, oh, there's a line that would be pretty close to those 4, but I also could have drawn it that way and it'd be pretty close to those 5. So which way is it? There's none. So this is no correlation, or relatively no correlation. Correlation. Okay. All right, number 3, make your own scatter plot. So we have some points. We have a plot. We're just going to put them on here. So our first point is at 1, 3. So that's 1 over and 3 up. Our second point is at 1 and 1.5. So that's right there. Our third point is at 2 over and 1 up. And then we have one at 2 over and negative 1/2. And then we have one at 3 over and 1 down. And then we have one at 3.5 over and 1/2 down. And we have one at 4 over and 2 down. So these are my points. And now we want to look at our points and say, is there any correlation to them? And I would say that there is a negative correlation to this. If I draw my line something like this, it gets pretty close to most of the dots. And this has a negative slope. So my correlation is going to be a negative correlation. Okay, on page 3, we have a graphic organizer, and it tells us how to use a line of fit to model data. So basically, we're going to use a scatter plot. We're going to draw our scatter plot. We're going to draw a line of best fit, so the line that goes through it the best way we can think of. And then we're going to find the equation of that line. Okay, so step 1 is to make a scatter plot of the data. So plot all the data points. Step 2 is decide whether the data can be modeled by a line. If it can't, then we're done. So in other words, if there's no correlation, we don't have to worry about it. Okay. Step 3, draw a line that appears to model the data closely. There should be approximately as many points above the line as below it. Okay. So if you have a scatter plot, you want to draw the line of best fit so that if I went through and counted all the green dots above and all the green dots below, they should be about the same. And the total distance of the ones from above and the ones from below should also be the same. Okay. Then we're going to write an equation using 2 points on the line. Okay. These line points do not have to be actual data plots. So usually you pick something like, say, oh, I'll just create this one and this one. Looks like places where they cross evenly. And then we model our line based upon 2 points, which we've been doing for a while. All right. So number 4, our last problem here, write an equation to model the data. So game attendance, the table shows the average attendance at a school varsity game for various years. Write an equation that models the average attended at the varsity basketball games as a function of the number of years since 2000. Well, year 2000 is exactly 0 years since 2000. Year 2001 is 1 year. Year 2002 is 2 years and 3 years and 4 years and so forth. So when we get to 2006, that's 6 years since the year 2000. All right, so now we just need to plot these points to start with. Okay, so 0 is supposed to be 488. So 475 is halfway, so 488 would be somewhere right about there. 1 is supposed to be 497. That's going to be really close to 500, but not quite. 2 should be 525. That's supposed to be exactly halfway between 500 and 550. 3 should be 567. That's going to be about there, somewhere between 575 and 550. Year 4 is supposed to be 583. So 583 is going to be about there. Year 5 was supposed to be 621. 621 is almost halfway up. And then year 6 was 688, which is pretty darn close to the top there. Now you could definitely see that this looks like a B modeled with a line. All right, so here I'm going to grab the ruler tool out of here and try to make the best line of best fit. So we'll go into the menu and get a ruler out. Okay, so I got my ruler. I'm trying to line it up. I've got 2 points above and I got a good number more below. So let me scroll this down a bit. Okay, and I'm going to go with about right there. Now I have 1 on it, I have 2 above, and I have 4 below. But the 2 that are above looks like they're about the same total distance as the 4 below. Okay, so I'll go ahead and draw my line. So this is my line of best fit. Okay, I get my ruler out of the way. And now I'm supposed to pick 2 places on the line so that I can do an equation with it. Okay, so I'm going to pick, it looks like year 7 is almost exactly 700. So this is 7 and 700. And then I'm going to also pick, let's see when else it looks pretty close here. I got, it looks like at year 0, we're a little below 425, so I'm going to call that year 0 and 400 and, let's see, 470. Okay, so here I'm eyeballing 2 points, as close as I can think of to get them. Okay, so I'll take these 2 points, 0 and 470, along with 7 and 700, and we're going to make an equation out of it. Okay, so we're going to compare the year in our attendance. So our attendance is our output at some given year, and we need to find the slope. Okay, so my slope is going to be 700 minus 470 over top of 7 minus 0. So 700 minus 470 is 240 over 7. And I'm going to get the calculator here. Oops, I'm sorry, that's 230 over 7. And then I'll divide it. And we get about 32.9. So we're going to call our slope 32.9. And then it's over number of years. And then I have a y-intercept of 470 already. So here is my equation that says the attendance at any given year is equal to about 32.9 times the year plus 470. Okay, so write an equation that models it, and there's our equation. So this completes our notes. Next time in class we'll do this. We'll plot some scatter plots. We'll draw a line of best fit, and we'll figure out the equation that goes through it. And then we'll also work on how do we do this with the calculator, because the calculator will calculate that line of best fit for us. All right, I'll see you in class next.